How are you, everybody who is watching this fantastic video? My name is Sir and Engineer Olenjolai TAYAI from the beautiful country, United Republic of Tanzania. I'm very happy to have you today. I'd like to welcome every viewer. And I'm a Tanzanian, and this is our national flag. I would like just to let you know that we still love our beautiful country. So I would like to take this opportunity, first of all, to welcome you into one of our online institutions that called Undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM. Again, I would like just also to take this opportunity simultaneously to welcome you into one of our YouTube channel, because we are providing and we are distributing these contents by using different platforms. But one of the platforms which are using currently is YouTube channel. We have one of our YouTube channel official called the Online Diploma Polytechnic Institute of Tanzania and square bracket OLENJOLAIM. So we are here really to train, to mentor undergraduate students who are pursuing different programs in engineering and science. So if you are an undergraduate student, whether first year or second year, I know that during your studies, you have to cover, or you have to spend possibly at least 3 to 4 semesters in advanced in basic in high engineering mathematics. So these contents are for the class. This class is for the first year in some of the institutions, or second year. Okay. Second year bachelor in engineering, okay, or bachelor in science, okay, bachelor in science. So in some of the institutions they call it NTA, NTA level 7. So NTA level 7. So these contents they cover during the NTA level 7. So I know that possibly you are wondering, or you have been looking for the solution, so you have been experiencing so many problems on learning higher engineering mathematics or higher scientific mathematics. So you've been trying different alternatives and possibly have given up. Don't give up. We still have, there is another solution, so another options. The options is be an active and permanent students of Online Undergraduate Polytechnic Institute of Tanzania, and then you have to make sure that you go from one lecture to another lecture. For example, this is lecture 6. It means we've done a lecture 1, lecture 2. First of all, we begin with lecture 0, lecture 1, lecture 2, lecture 3, lecture 4, lecture 5, lecture 6. So this is lecture 6. So if this is your first video, please check in your official YouTube channel that's called Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Then you will find all the previous 7 lectures, lecture 00, or lecture 0, lecture 1, lecture 2, lecture 3, lecture 4, lecture 5. So 6 lectures are already uploaded, and you can access them at any time and anywhere. So possibly one of the questions that you are asking yourself, how can you get registered? Because in a normal or in a physical, because this is the online institute or online institution, it's not actually the online a physical institution, so physical college or physical university. We don't have that at the moment, but we are sharing all our contents with every student worldwide, but we are focusing on the curriculums of United Republic of Tanzania, where we have TCU curriculums and NACTE curriculums. So TCU is Tanzania Commission for Universities, and also NACTE is National Council for Technical Education. So today our focus will be focused on the curriculums of Tanzania Commissions for Universities, and all the universities which under the TCU, they can benefit on these contents, because we are focusing on knowledge-based when we are teaching them. Whether you are international students from any continents, you're warmly welcome. Mathematics is a universal. Higher engineering mathematics is a universal subject. Higher scientific mathematics is a universal subject. So you can learn these contents, possibly that in this style or in this way of we are arranging according to the syllabus, but also you can adjust a little bit. But the issue is you have to remember that you'll find contents here for undergraduate students, that the specializations or the uniqueness of our official YouTube channel that called the Online Diploma, Online Undergrad Institute of Tanzania square bracket OLENJOLAIM. So the next question, whenever you go into any physical institution registration, any physical institution or any physical college or any physical university, during the first week or second week, first week or 2 weeks, you'll be registering yourself. So how you can register yourself in Tanzania in online undergraduate polytechnic Institute of Tanzania square bracket OLENJOLAIM. So what? So here we are just doing one lifetime, one lifetime registrations. Okay, so you are doing permanent registrations. You should not do maybe every semester. We don't have semester registrations, every semester registrations, or maybe every year registrations. So you just do once, it's enough. If just to do the registrations once, it's enough. And we can access our content. So the first step, you should have an email, have either Yahoo or Gmail. Okay, or Gmail, or okay, Gmail what? Email. Okay, that's the first step. The second step, sign in YouTube. Sign in YouTube, search engine. Then the third step, we ask you that to search our official YouTube channel that called Online. I'm writing abbreviations: Online Undergraduate Polytechnic Institute or Polyinstitute. Okay, Online Undergraduate Polyinstitute, Polyinstitute of 14, Polyinstitute of Tanzania. So Polyinstitute of Tanzania. So Online Undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM. So you have to search, just write this official YouTube channel. It's not online diploma, what is minor mistake. So just search online undergrad. These abbreviations of undergraduate Polyinstitute of Tanzania square bracket OLENJOLAIM. So when you search there, then you will see at the bottom, at the bottom of right hand side, you'll see the buttons which have been clicked, have been written as click. Then there are words here which have been written subscribe. So click subscribe. So click these software buttons that written subscribe. Subscribe. Once you click these buttons, the background color will change and becoming okay, it is changing from gray into gray color, and this word will change into subscribe. And then we have the bell, right? So click again the bell and choose the options of all. So when you are done with these steps within a minute, then you are done. But again, we insist you to click another icon which you see there, icons of like, if you like or dislike, or you can click also the icons of share to share these contents with others. If you do that, you have already registered yourself, and also you share these contents with other students across the country of Tanzania or worldwide. So after doing all of those steps, let us go into today's lecture, which is lecture 60. We are in departments of high engineering and scientific mathematics. The course of the day or modules is called several variables calculus. We are in chapter 1 that's called several variables functions, or functions of several variables. Okay, I've just interchanged here. It is function of several variables. Then the subtopic is called partial derivative, and we are lecture 60, partial derivatives of f of x, y, z. Means partial derivatives of three variables, of functions of three variables, but then abbreviations. Partial derivative of a functions of three variables. So let us go into the sessions. The quick review of lecture 5. In lecture 5, we introduced it to you about, remember that we have the concept that we call the differentiation. Okay. In differentiation, we have two types of differentiation, depending on the number of variables of the function. So we say that we have derivative, if we have ordinary derivative, this is called ordinary derivative. Okay, ordinary derivative actual of what? Of a single variable function, ffx like this one. And this one is the one that we've been writing, the y, the x, we are showing the or ffx like this, etc., etc. But against we have another types of derivative which we call the partial derivative. So this partial derivative, we say that it's a technique we use to differentiate function of of three variables, which is ffx, y, z, of 2 to 3 variables. For example, that a function like this one, or maybe you can differentiate maximum just because we are doing three-dimensional. So partial derivatives of functions of the 2 variables and the functions of 3 variables. So under this case, we say against that if you do remember that we have 3 cases. We have first order, okay, you can have first order, partial derivative. We can have also second order, partial derivative, okay, partial derivative, and also you can have got the higher order, more than second order. So we got the higher order partial derivative. So we've been discussing about first order partial derivatives, and we told you that in this context, if you have a big picture, we are going to deal with 2 first order partial derivative of of the functions of the 2 variables, of x, y, for instance. So today we are focusing on the function of 3 variables. So this is the big picture. And remember the difference means that here we are using these notations, not like these ones. Or we can use either ff1, x, y. So we have different notations. In case you want to get too much details, you can access lecture 5 in our YouTube channel that called Online Undergrad Polyinstit of Tanzania Square Bracket OLENJOLAIM. So make sure that you watch it because the foundations of lecture 6. So let us go to today's concept. So you say that in the first order, so we say that, so let us focus on this, that first order partial, first order partial derivatives of a function of 3 variables. That's the focus that we have to focus in this session. So remember that the concept always is ordinary derivative. So from what? From the concept of first principle of single variable used to say that if you are looking the derivative of any function of a single variable function ffx, say this is equal to the limit as the small change in x approaches to 0, then you say ffx plus small change in x, comma y minus ffx. No, excuse me. So you say that ffx plus small change in x minus ffx is about the small change in what? Small change ffx plus small change in x minus ffx of what? Small change in x. Okay. So at the we used to say that maybe ff dash of x, we used to say that limit as h approaches to 0, then here we have ffx plus h minus ffx of what? Over h. So either the formula is Coet or we call it the first principle. So from this concept now, we say that the first principle, so from that one, we say that we can deduce what? The first principle, can deduce the first principle of the function of three variables. Say a function of three variables, you mean that f of x, comma y, comma z, for instance. Okay, so how can we find? So now, ladies and gentlemen, I'm going to teach about first principle of partial derivative of a functions of three variables. Okay, so we say that for this case, we say that the partial derivative. So we are going to have the partial derivatives of the function of this three variables functions with respect to each variable when other variables are being kept constant. So we have to find partial derivatives of the function of x, comma y, comma z when y and z has been kept constant. This is equal to limit as small change in x approaches to 0. Then you have f of x plus small change in x, then comma y, comma z, then minus what? Minus f of x, comma y, comma z, then divided by small change in x. So to just rewrite, we say that, to rewrite it properly, say that this is limit as small change in x approaches to 0, then you have f of x plus small change in x, then comma what, comma y, okay, comma y, comma z, minus f of x, comma y, comma z, divided by small change in x. So this is the general formula. Okay. The second formula. So the second formula, we say that we can differentiate the same functions respective to y. So partial derivative of the function f of x, comma y, comma z. This is equal to what? Is equal to limit as small change in y approaches to 0. Then here we have f of x, comma y, plus small change in y. We have to keep z constant, minus what? Minus f of x, comma y, comma z, divided by small change in y. So to write, say limit as small change in y approaches to 0, then we have what? We have f of x, comma y, plus small change in y, comma z, minus what? Minus f of x, comma y, comma z. Then divided out small change in what? In y. So these are the formulas of the first order derivative of what? Of the functions of three variables. Okay? Then the third derivative, we have to differentiate the function f of x, comma y with respect to z, y, x, and y are kept constant. Again, in case you feel from your heart that you want to offer our Father, who is in heaven, our God, our mighty God, you are free willing thanksgiving for this program. Don't just stay to yourself. You may send your free willing thanksgiving to 0759745331, or in case you want to do the bank transactions, you may go to the descriptions on your left hand side, on your right hand, on your left hand side of the video, and then so you see descriptions. Just click the button that says being written show more. You'll see more information concerning about some of these courses. Okay. So the partial derivatives with respect to z, partial derivatives of the function f of x, comma y, comma z, this is equal to the limit as small change in z approaches to 0. Then you have f of x, comma y, comma small comma z, plus small change in z, minus f of x, comma y, comma z, divided by small change in z. So just to write it, we say that partial derivative with respect to z of f of x, comma y, comma z. This is equal to limit. Just I want to rewrite it clearly. Small change in z approaches to 0. So we have f of x, comma y, comma z plus small change in z, then minus what? F of x, comma y, comma z divided by what? Small change in z. So this is another formula. Okay, so you have three. So you have to find three derivatives in case we are looking for the first order partial derivatives of the functions of three variables. You have just differentiated a given function with respect to one variable while other two variables have been kept constant. So for instance, here we have differentiated the function f of x, comma y, comma z with respect to x, y, and z are kept constant. So we have changed only what we have considered as a small change in x. Here differentiated the function f of x, comma y, comma z with respect to y, x and z has been kept constant. And here we have differentiated the function f of x, comma y, comma z with respect to what? With respect to x, with respect to x, y, with respect to z, y, x and y has been kept constant. So this is the process. All right. So this is the process that we have been experiencing, or we have been doing, or we have to do as mathematicians. So now let me give you some examples. Remember that in this lecture 6, I'm going to solve also question number 4 in tutorial sheet number 1. Tutorial sheet number 1, which has been provided at the College of Engineering and the Technology, called the Coet, okay, at the University of Dar es Salaam. So stay tuned. So this will be example 11. So let me give you examples and see how we do this. We differentiate. So the question said that given function f of x, comma y, comma z, this is equal to what? E power x, y, then plus what? X squared, y, what? No. X squared, then cube. Then plus what? Plus y squared, cos of what? Cosine of z. Okay? Cosine of z. Then we say that find partial derivative of the given function, which is f of x, comma y, comma z with respect to x. Also find partial derivatives of the function f of x, comma y, comma z. We have never discussed this concept in advanced education or in ordinary diploma. So we know that we are teaching undergraduate students for the first time. So partial derivatives of the function f of x, comma y with respect to z. So you have those three first order derivatives. You can pause the video and try. Pause the video and try to solve example 11 on the rough paper, and then you check the solution. So you have a responsibility to find the derivative solution. Okay? So we say that we have been given a function which is here we have product of exponential functions and linear function. Here we have here we have a linear function of the two variables, and here we have the products of linear function and the trigonometrical function. So solution. So the first stage when we want to, the first stage is we say that let us keep y and then constant to find what? To find partial derivatives with respect to x of f of x, comma y, comma z. Okay? That is. So we'll be given a function f of x, comma y, comma z is equal to what, ladies and gentlemen? E power x, y, plus what? Plus x squared, z cube, then plus what? Plus y squared, cos of what? Cos of z. Okay, so to find the partial derivative of this function f of x, comma y, comma z is equal to what? So you have to differentiate this function with respect to x when y and z has been kept constant, but we don't have z in this part. Here we have to find the partial derivative of x squared z cubic with respect to x plus what? Partial derivatives with respect to x of what? Y squared cos of z. Wow. So this, in this case, you say that partial derivative, so d dx of what? F of x, comma y, comma z. This is equal to what? So we differentiate this one respective to x. So if we differentiate this one respective to x, we get e power x y, and then plus what? Plus this one. So we say here we have 2x, and a z cubic because we kept it constant, and y have kept it constant. So differentiate this with respect to x. We don't have any x variable. So this is an, we have kept the y and z constant, so this is the constant. When you differentiate a constant with respect to x, the answer is equal to 0. So therefore, ladies and gentlemen, the partial derivative of the function f of x, comma y, comma z with respect to x, this is equal to e power x y plus what? Y is x z cubed. So this is the response. At the first part of the question, we go for the second step. Second step, we say that we have to keep x and z constant to find the partial derivative with respect to z of the function x, comma y, comma z. With respect to y, excuse me. So to find this one, partial derivative of the given function with respect to y, f of x, comma y, comma z, this is equal to what? So you have to differentiate the first part of the function with respect to y, where we have e over x, while x has been kept constant, plus partial with respect to y, partial derivative respective to y, respective to y of what? X squared z what? Z cube. Okay? Then plus what? Plus partial derivatives with respect to y of what? Y squared cos of z, like this. Okay, cos of z, like that. So then we say that this is partial derivative with respect to y of f of x, comma y, comma z is equal to what? To differentiate this one with respect to y, then we get e power x in standard form, let's say the partial derivatives of y, okay? Then plus what? So here we don't have, so we have what? X squared, z cube, partial derivative with respect to y of 1, which is equal to 0, plus the second part. So this is contents for undergraduate, first year or second year undergraduate at University of Dar es Salaam and related universities or other universities in Tanzania. Students, or used to teach our students during the first semester of second year. So then plus what? So the next part is what is constant here, cos of z is constant, then partial derivative with respect to y of what? Respect to y of y squared. So then we say that the second derivative with respect to y of f of x, comma y, comma z, this is equal to what? So here we are. So you have e power x, we differentiate y with respect to y. So you get to 1. So it's equal to e power x. Okay? Then plus what? Here we have what? X squared, z, we differentiate 1 with respect to 1. So whenever you differentiate constant with respect to any variable, the answer is 0. Then plus. Here we have cos of z, which is kept constant, or we have kept it constant, differentiating y squared. So the answer is twice y. So ladies and gentlemen, so we say that the partial derivative of the function f of x comma y respective to y, this is equal to e power x, then plus what? Plus twice y cos of z. So this is the response. Wonderful. So check your try. If you got it, congratulations. So we go for the third step. We have to find the derivative. So you say that it will find, so we have to keep x and y constant, constant, to find what? To find partial derivatives respective to z of what? Of f of x comma y comma z. So now, so partial derivatives of the function f of x comma y z comma z with respect to z, this is equal to what? Is equal to partial derivatives with respect to z of the first part, which is e power x y, plus partial derivative with respect to z of what? Of x squared. X squared times z cube. Then plus partial derivatives of z. Then what? You have y squared cos of z. Right? Yes. Okay, fine. So then we say that this is equal to what? So there, so this is constant. E power x, we kept it constant, times y is constant. Then we differentiate 1 with respect to z. Plus. Differentiate what? The next function is x squared, we kept it constant. Then partial derivative with respect to z of what? Of z cube. Okay, z cube. Then plus what? Plus y squared. Then partial derivative with respect to z of what? Of cos of z. So into the case now, we say that we are looking at the partial derivative of f of x comma y comma z. This is equal to what? So partial derivative with respect to z of e x y, that is equal to 0. It's equal to 0 plus what? The second part, we differentiate this with respect to z is 3 z squared. So plus 3 x squared z squared. Then we differentiate, we have y squared cos of z. So this is y squared, differentiate cos of z, we get negative sign of z. So then we have partial derivatives of z of the function f of x comma y comma z. This is equal to this is equal to 3 x squared. So here it was plus, so minus what? Minus y cube sine of z. So this is the response. So x squared y minus y squared z squared. So that's the end of solution. That's the end of solving. The end of solving example 11. Okay. So let me give you the homework. Okay, because you know. So example 12, this is homework. This is homework 6. Okay, homework 6. The question, given a function u is equal to y sine of x, so sine of x plus x plus square y plus z e power y, then cos of x, When we say that find partial derivatives of u respect to x, partial derivatives of u respect to y, partial derivatives of u respective to z. So find those. So it's a very simple question. You just have to review what I taught you in example 11, and then you do these questions quickly as possible. So ladies and gentlemen, allow me right now to take you into the conceptual question. And this is example 13. Refer tutorial sheet 1. Tutorial sheet 1 of NT 261 of several variable calculus at the University of Dar es Salaam at the reference syllabus revision. And this is question number 4. Ladies and gentlemen, here the question. An electrical engineer designs the connection or design the connection of 3 resistors. R1, R2, and R3. Ohms in parallel. Why was he connecting these resistors in parallel? In order to reduce what? In order to decrease the resistance offered to the flow of electric current at the end. Because if you connect resistors in series, you are increasing the resistance against the flow of electric current, so the conductor, also the resistors, and while you are decreasing amount of electric current that will be flowing in that equivalence resistance. When you connect 3 resistors in parallel, then you reduce the equivalence resistance, means the total resistance, and increase the amount of currents that will be flowing through the connections or through the network. We call the electrical network. So I am very interested in this stuff because, this is one of area of my shifting because I'm an electronics and telecommunication engineer. So simply I'm an electrical engineer and computer scientist. So this is one of the interesting questions to me for the rest of my life. So to make it in parallel, to make R ohm resistor. Make R ohm resistor. The value of R can be formed from the relation one over R is equal to 1 over R1, 1 over R2, 1 over R3. Then the question, find the value. Find the value of partial derivatives of R respective to R2 when R1 is equal to 30, R2 is equal to 45, and R3 is equal to 90 ohms. The question. So you have to kick it, you have to enjoy it, ladies and gentlemen. It's a very interesting question. It's not a formula that I should give you the homework at the end of the session. Today I give you the homework at the middle of the session or middle of the lecture. So make sure that you do and submit your homework in the comment sections. In case you have any question, don't hesitate to ask in the comment section, please. So we'll be given a question that an electrical engineer, you possibly, or a mechanical engineer, just you can place, okay, designs the connections of 3 resistors R, R2, R1, R2, and R3 ohms in parallel to make R ohm resistor. The value of R can be found from the relation 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Find the value of partial derivatives of R respective to R2 when R1 is equal to 30, R2 is equal to 45, and R3 is equal to 90 ohms. So if you check these questions, actually it's really testing us about our understanding. And this is because as I say that it's one of the tutorial questions, because we are not only teaching you concept in this in online undergraduate Polytechnic Institute of Tanzania, but we are also teaching you how you can solve the tutorial questions. So we want to prepare you in order to master well your continuous assessment, and we want to prepare you also in order to master your final or your university exams that is you have to do at the end of the semester. Again, so remember that our main objective in online undergraduate Polytechnic Institute of Tanzania is to see our continuing and graduate students solving real-life problems. So you have to think how you can use the partial derivatives on solving a particular problem in your community, or particular problems in the nations, or particular problems in your regions, or particular problems in your zone. So whatever the case, and even in your community. So one of the applications is this one, that in case you want to find the partial derivatives of R with respect to R2, it means you keep other variables or other variables which are 1 and R3 constant. So how are we solving this problem? So you have to follow the steps I told you and the techniques that I have already told you in lecture 5 and lecture 6. Okay, solution. So the first step. You have to identify that you have to identify first of all that the size of the functions or the number of independent variables that are available in the function. Okay, so you say that the given function depends on 3 variables. And these 3 variables are R1, R2, R3. Yeah, yes, students, when we've been dealing with sorting with functions, so with x, y, z. So usual from what you know that f of x, comma y, comma z, just this one, you have to transform that. Instead of f today we have r, and then x1 is equivalent to R1, and x2 equivalent to R2, and no, y is equivalent to R2, then is equivalent to R3. All right. So that's the concept that you have to understand. Okay? So it means that it's R of R1, R2, and the R3. Again, you have to check what you've been asked to find. You have to find the first partial derivative. So it means that the partial derivative of R with respect to R2, so we say that this is first order partial derivative. First order partial derivative of what? Of R with respect to what? With respect to R2. Y, R1, R2, and R3. Oh, Y R1 and 2, Y R1 and the R3 are kept constant. So these are kept constant. Okay, so this is the case. Okay, so those three resistors are being kept constant, but we'll be given the value of R1, R2, R3. Why? In order to find the value of R. Okay, so in order to find the value of R, but we'll see why should we find the value of R later on. So the second step now, we say that we have to keep what? R1 and the R3 constant to find the first partial derivative of R with respect to R2. Okay? So how we can do this one? So we have to differentiate the left-hand side with respect to R2, where we have 1 over R. This is equal to partial derivatives with respect to R2 of what? 1 over R1 plus partial derivative with respect to R2 of 1 over R2, then partial derivative with respect to R2 of 1 over R2. Alright? So on the left hand side, remember that this is equivalent to, right, partial derivative with respect to what? R power negative 1 is equal to, so remember that we have kept it constant. So we've kept the constant R1, so we take it outside of the derivative. So we have 1 over R1, partial derivatives with respect to R2 of 1, then plus what? Then plus what? So then plus partial derivative with respect to R2 of what? R2 or negative 1, and then plus what? We have kept it 1, we have kept it R3 constant, so we take it out. So 1 over R2, partial derivatives of R of 1 of the constant to 1 with respect to R2, just like this. So if we differentiate this one, what are we going to get? Listen carefully. So differentiate this term, we have negative 1, then we have terms what? R power negative 1 minus 1, then we have partial of R with respect to R2, just like what you used to do in other cases when you're differentiating y power negative 1. So this is just to differentiate y power negative 1 with respect to y. So negative 1 comes here, and then say y power negative 1, but we still have dy dx. So remember that technique, the same technique we are using here for differentiate this one. So here we have 1 over R1, 1 over R1. If you differentiate 1 with respect to R2, this is 0 plus what? So if you differentiate this one again, we have negative R power negative 1 minus 1. Okay? And then plus what? 1 over R3, then times what? Times 0. Alright. So let us continue. So remember that, don't forget to register permanently in Tanzania or in online Undergraduate Polytechnic Institute of Tanzania in square bracket Olenjolai for you to benefit with all the lecture resources and all the contents that we are providing to serious students. So on the left hand side, we are going to have negative r or negative 2, then partial derivative of r with respect to r2. This is equal to what? The first term will be 0, and the next term will be negative r or negative 2, and then plus what? Plus 0. Okay? Plus 0. So again, so this is r2, remember that. So again, we say that having r power negative 2, this is equivalent to what? This is equivalent to negative r1 over r squared. Then partial derivative of r with respect to r2. Alright? On this side also, we have negative what? So we have negative 1 over r2. So negative and negative will cancel. So if you divide by negative 1, okay? So if you divide by negative 1 over, but remember that this is r2, ladies and gentlemen. Negative 1 over r squared. On this side, divide by negative 1 over r squared. So the partial derivatives of r, the formula for the finding partial derivatives of r respective to r2, this is equal to what? So negative over negative is 1, it's positive. So here we have 1 over r2 square, then divided by 1 over r square. So this one is equal to 1 over r2 square times r square over 1. So partial derivatives of r is respective to r2. This is equal to what? This is equal to r over this r ohms or equivalent resistance r over r2 squared. R2 squared. Okay. So if that's the case, let us call this as equation 2. While equation 1, it is this one. 1 over r is 1 over r1 plus 1 over r2 plus 1 over r3. So suppose that this is equation 1. Okay, so now we have the formula. Do we have the value of r2? Yes, r2 is 45 ohms. We have the value of r? No, we don't have it. We have the value of r1 and r3. Why are we given r1 and r3? Because that we the value of r1, r2, and r3, if you substitute them in this given formula, you can get r1. So we go for the next state, and this is the steady state. I believe that you're enjoying the beauty of higher engineering mathematics, and I believe that you're enjoying the beauty of several variable calculus, and I believe that you're enjoying the beauty of partial derivatives of several variable functions. Okay, so ladies and gentlemen, here we have 1 over r is equal to 1 over, so we go for the steady state. So the steady state, we say that let us use the equation 1 to find what? Equation 1 to find the value of what? The value of r. How? We just do the simple algebraic expressions of fractions, adding fractions. So 1 over what? So the first value of r is 30. So 1 over r1. So let me write the formula first. 1 over r2, 1 over r3. So we say this is 1 over r is equal to 1 over 30, 45, 1 over 45, 1 over 90. Alright? So the LCM is 90. So 90 over 30, it's what? It's 3. 3 times 1, 3. 90 over 45 is equal to 2. 2 times 1, it is 2. 90 over 90 is 1 times 1 is 1. So 1 over r, this is 1 No, this is equal to 6 over 9. Simplify. If you simplify by 3, by what? By 6. By 6 you get 1. By 6 you get 15. Cos 15 times 6 is equal to 90. So you have 1 over R, 1 over 15. So cross multiplication. So if you cross multiplication, R is equal to 15 ohm. So you see that the equivalent resistance is less than all the three values of resistance. Means you see that R, this is just for the engineers, R is less than R1, okay? And R1 is less than R2, and R2 is less than what? R3. So equivalent resistance means if you arrange resistors in parallel, the main objective is to reduce resistance in order to increase the amount of currents that will be flowing through that connection or through that network. That's the principle that we are applying in electrical engineering, in electronics, in telecommunication engineering, that in case we are dealing with impedance, because it's however, in case of impedance, we have to consider also about the angle. But in case of resistance, just to consider the scalar quantities. So this is the value of 40 of R. R is equal to 15. So suppose that this is equation 3. Okay? So we say that the first state, we say that substitute equation 3 will not in equation 2. Equation 2 above. So substitute the value of R in this equation to find the partial derivative of what? Of R. So partial derivative of R is respect to R2, where we say that this is equal to R over R2 square. This is equal to what is R? The value of R, it is what? The value of R, it is 15 ohm. Over the value of R2, it is what? The value of R2, it is 45. That is square. So this is equal to what? Is equal to, if you simplify 15 with 45, it means 45 over 15 is equal to 3. So square. So the answer, it is 1 over 9. So now we have got the response of the question that have been asked. I would like to remind you to remember to subscribe in our YouTube channel for you to get notification. Why should you subscribe? You are doing the permanent registration, but there's a great advantage for you. We are expecting, or we are doing these programs consistently, and we're expecting to have or to record, to have live recordings of more than 500 live videos of undergraduate engineering mathematics and undergraduate scientific mathematics. So for you to get notifications once we upload, because in a day at least we add 1 video. So for you to get notifications, once we upload any new video, please subscribe. So therefore, the value of partial derivative is respective to R2 of R is equal to 1 over 9. The response for the question number 4 for the, from the tutorial sheet of several variable calculus, or we call it the MT 261 at University of Dar es Salaam, or especially in College of Coet, College of Engineering and the Technology. So that's the value. So it means partial derivative of R respect to R2 is 1 over 9. So enjoy the beauty of higher engineering and scientific mathematics. Ladies and gentlemen, this is the end of lecture 6, which has been titled as partial derivatives of first order partial derivatives of the function of the variable. So I thank God who have been with me, and I thank God who have created me in his own image and likeness. I would like to invite you to join me in the next session, which will be the lecture 7, when I'll teach you about second order partial derivatives. And then lecture 8, I'll teach about higher order derivatives, but I will not go into too much details according to the curriculums of Tanzania does not allow me to teach undergraduate students in details about higher partial derivatives. But I will just give you the concept to understand where the field of mathematics is heading to. So I would like to remind you to do a few things. Number 1, I ask you to subscribe and share this content. Subscribe in order for you to get notifications once we upload lecture 7 or 40 of self-variable calculus. And then again, we ask you to share these contents with some other undergraduate students in the college where you are studying in Tanzania or in Africa or in Asia, in America or in Europe, because this is a cross-cutting subject or it's a universal subject. Higher engineering mathematics, it has been studied worldwide in every continent, in every country. Again, the second thing I would like to inform you that make sure also you go into you read the descriptions of this video by clicking the software buttons that are written show more in order for you to get some other informations. Some of the information that you are going to get, you'll get also that in case you feel from your hands that you want to offer God your free will in thanksgiving through the bank transaction, you'll see the bank account name, the bank account, and the bank account name and the bank account number, and also the bank, the name of the bank for the local transactions. Again, another thing that you'll get in reading the descriptions, you'll see the link of the video that will take you into our online undergraduate library, where we have books and scientific calculators that we would like to equip our students in order for them to master the beauty of higher engineering mathematics, higher scientific mathematics, and the engineering and electrical engineering fields, because that's the area where we have specialized. So may God bless you and keep you until we meet in the next lecture. This is Olenjolai, and also you can call me Engineer Olenjolai. Remember that Sir Olenjolai does not know everything concerning about several variable calculus. I just know small portions of it, but I have a responsibility or an assignment to teach others about what I know. So join me in the next session. Stay tuned and focused, and may God bless you until we meet in the next session. Okay, so enjoy the beauty of higher engineering mathematics.